Hi everyone, my name is Michael Schinkets and I'm a software developer at sCrypt. So throughout this series of tutorials, I will be your guide. The aim of this series is to teach you how to using sCrypt develop fully fledged Web3 applications for the Bitcoin SV network. So in case you don't know what sCrypt is basically a TypeScript framework that makes the development of smart contract really easy. So instead of learning a new language, you can do everything in TypeScript. So if you already have a little bit of programming experience, it should be really easy for you to get going. In case you want to learn more, go check out our website, sCrypt.io, that contains links for the documentation of sCrypt and also some other useful resources. So let's get going, happy coding and enjoy! So let's take a quick look at what we're gonna be building in this tutorial. So this will be a simple voting app. This will be basically your window to your smart contract, which is deployed in the background. And the smart contract's job is to keep track of votes. So in this case, it's 2 items, 2 phones. So users will open this up and just vote for one. So let's try to vote for an iPhone. The sCrypt wallet will prompt you to create a transaction, so you just hit commit. And it will update the smart contract in the background. So using any block explorer, you can just simply take a look at the transaction it created. And also the most important thing about this app is that if you vote, all users that will open this interface will also receive a notification for it. So let's vote for another one. Oh, let me just quickly open another client. And let's vote for one. Commit. Go. And the other one got a notification as well. Right, to start off, we're gonna create a blank React project. So to do that, we're gonna issue the following command. So npx create React app, voting, and the template's gonna be TypeScript. So this will create a blank TypeScript React project. So let's run it. Once done, we can go into the newly created directory and initialize a Git repository. So git init and git add, git commit, initial commit. Here you go. And now we can run npx sCrypt-cli init. This will in turn create demo smart contracts within our newly created React app, which we'll modify and use later on in the web app. Let's open up our project in VS Code. Take a look at what we got. Right, let's make it a bit bigger. Okay, so under source contracts voting.ts, we'll have just basically a demo smart contract. Now this smart contract is a simple counter smart contract, but we will modify the smart contract now to be the smart contract for our voting app. Additionally, our project will also create all the boilerplate that we will need in our web application. So this is just a basic React app, so nothing special. We will modify everything in these files later on, but for now, the project provided us with just a random private key, but because we will be using sCrypt wallet, we will need to import this private key from our wallet. In order to use sCrypt wallet, you will need a Chrome-based browser. You'll go over to sCrypt.com. If you haven't already, just click install, and it's just a basic Chrome extension. So I already have mine installed, and make sure you switch to testnet because we will be testing our application on the testnet, not the mainnet. And I already have a testnet wallet with some funds. Now yours, initially when you create one, yours will be empty. So what you can do is simply copy your address and go over to sCrypt.io/Faucet. paste in your address, and this will give you some testnet Bitcoin free of charge. Then we can simply go to our wallet, go over to settings and click export private key. I'm gonna put in our password and then just copy the key and paste it into this variable. Save. We did this simply because later on, when we finish writing the smart contract itself, we can simply deploy the contract from the command line, and it will by default use this private key defined in the environment file. Okay, so let's get to writing the smart contract itself. Because the command created a bunch of boilerplate for us, which we won't need, it's best to just tidy it up a bit. So let's do this, just so that it doesn't confuse us. And our smart contract will probably have only a single public method, which will be the public method for voting. So let's call it votes. Once we got that, let's define some types. So we're going to do export type, because every candidate will have some name. I'm going to just define an alias for a byte string called name, and then we're gonna define the type for the candidate itself. Candidate go, and it's gonna be a composite of two properties. So first it's gonna be the name, and the second one gonna be the number of votes received. This should be a big integer. Okay. Now let's define a contract property. And we're gonna call it candidates. Candidates. And it's gonna be fixed array of candidates. And yeah, let's also define how many of them we'll have. So let's do export type, and it's gonna be 2, because we'll vote for 2 phones. Yeah. Oh yeah, of course. This is gonna be a constant, not a type. And also keep in mind that this property will be stateful, because it will change how many votes each candidate have. So we're gonna pass in a true inside the decorator. So what we're gonna do now is just gonna make the constructor take in names. It's gonna be so a fixed array of names, and there we go. Then we're gonna just initialize the candidates array. So I'll do fill. Yeah, let's do name is gonna be, I just initialize it without any values first. So it's gonna be an empty string, and votes received, it's gonna be 0. Yeah, and we're gonna make it the size n. Import that, and then we can set the values. So we'll do smaller than n. Just a simple for loop, and for each iteration we're just gonna do set the value. Yeah, set the name. It's gonna be names I. Then the votes received is gonna be just 0. Alright. Okay, so now that we have the constructor, let's move on to implementing the public function. So the public function is going to take in a single parameter, which is going to be the name of the candidate. And what we got to do is we got to increment the votes received counter for that name when the method is called. So let's just loop over each one. Let's just do that. Oops. For each of them, we're gonna check the name is the right one. Name. And if it is, we're just gonna simply increment the counter. Do that. So now that the counter was incremented, the contract has to make sure that the next output will contain the code of the smart contract with the updated properties. So to get that output, sCrypt has a simple function. So let's just define a variable. It's gonna be byte string. Let's just do that. And it's gonna be this build state outputs. It's gonna take in just the amount of satoshis locked in the next output, and we can just make this the same as the inputs satoshis, which is this .context.utxo.value. Because each method call will also leave us with some change, which is gonna include a change output. So if the change amount is greater than 0, which is gonna concatenate another output, and it's gonna be this build change output. That's it. And now we're gonna assert that from the context that the hash of the next output is actually equal to the hash of these outputs that we just created. Now this line, basically what it does is it makes sure that during the contract execution on chain, the outputs that we built here inside the smart contract will actually be the same as the hash. The hash will be the same as the hash in the execution context, and it cannot be anything else. So in this case, you might have guessed this contract will pretty much never terminate, and as long as we keep calling the public methods, it will update itself. And for the smart contract, that's pretty much it. So just remove this dangling import and save. And now we can go back to the console and try to compile the smart contract that we just wrote. So we're gonna do npx sCrypt CLI compile. Hit enter. And here you go. The smart contract has been successfully built. So we can go, it will create a new folder called artifacts under the project root. And if we take a look at voting.json, it will be pretty much an ABI description and the compiled script code itself. So that will be the actual script that will be included in the transaction. All right. So now in a real world scenario, you might also write some tests for this smart contract, but in this tutorial, we're just gonna skip that and we're gonna assume that the code is actually correct. And perhaps in a future video, we'll also go over how to write a proper test for a smart contract. So now let's just go straight into deploying the smart contract. So we're gonna go back to the console and type npx sCrypt-CLI and deploy. Enter. Oops, and we can see that it failed, and that's probably because we haven't defined the constructor parameters in the deployment script. So I'm gonna go back and search for the deployment script. So it's gonna be under the scripts folder and open deploy.ts. And here we can see that we got two to-dos. So the first one is to adjust the amount of Satoshis locked into the smart contract itself. So we're just gonna make this 1 because there are basically no payments involved with our smart contracts. It's just basically a counter that counts votes. And the second to do is just to pass the constructor parameter values. In our case, that's just gonna be the candidates' names. So find them names. It's gonna be fixed array again. Names. It's gonna be do. And yeah, because it's gonna be phones. First one's gonna be an iPhone. Second one is an Android. Let's pass this in. Pretty much it. Oh, and because sCrypt smart contracts only know byte strings, not strings themselves, we gotta convert this byte string. This, and the second parameter is gonna be true. That means that the first string is gonna be UTF-8 formatted. So we're gonna do same with the second one. Okay, save. And now let's try to deploy it again, see if it works. Oops. Okay. And yeah, it's successfully deployed the smart contract on the testnet. So let's just check it in a block explorer. There you go. That's the output, which contains the smart contract code. Yeah, we can also verify that this source code actually belongs to this compiled script. So let's just copy the smart contract code itself in here. Click submit. And here we go. Now everyone will be able to see that this transaction actually contains code that was produced by this source code. Okay, so now that we have deployed the smart contracts, let's move to implementing the front end for it. Let's go back to our code and open the index file. Here, we're gonna initialize a sCrypt service provider. So we're gonna do sCrypt.init. And in here, we're gonna pass in the API key, which we'll get later on, and the network. So this is gonna be just networks dot, it's gonna be the testnet. And let's just import this. Okay. Now this sCrypt service provider will be basically our window to the blockchain. So instead of setting up a node ourselves or something like that, we can use this to listen for events, i.e. Smart contract updates live without setting up anything ourselselves. So in order to get this API key, we're gonna go over to sCrypt.io and we're just gonna sign up here. Now because I already have an account, I'm just gonna log in. Okay. And we're gonna have our API keys here. So we'll have a separate one for mainnet and one for testnet. So let's just copy the one for testnet, head over to source code, just paste it in here, save, and let's close this. Now let's just go over to app.tsx, and here we can start finding our layout. So let's just remove all this stuff. Save. Yeah, and because we're gonna use some fancy components, we're gonna install the MUI component library. So do npm install at MUI. I think it's okay. Let's go back to the code. And now that we got this, the MUI components, we can just do the table container. Inside this table container, we have a table itself. Here we're gonna have the table head, it's gonna contain 2 table cells. So let's just align it to the center. And the first one's gonna be iPhone. Second's gonna be on Android, right? Okay, now for the table body. Table body. So have 2 cells. In here we're gonna store the images, so I already have this component ready. It's gonna be box. First one's gonna be an iPhone, and the second one is gonna be the Android. So let's change that. Android. And of course, now we're gonna need the image files themselves. So iPhone, one for iPhone and one for the Android phone. So let's just open public, and I already got mine ready. So let's just put it in here. Oops, it seems like that didn't work. So let me just manually get it. That. Oh, wrong link. Yeah, okay, that works. And now for the Android. There you go. Now we have also the images themselves. Now what's missing is some buttons that will allow the user to vote. So let's just add those. Just add another row. This. Also this. Add a button. And inside of it, just put in like a thumbs up emoji. Also, let's add a name. And the first one's gonna be iPhone. Okay. We're gonna put this here. And the second one is gonna be, of course, Android. Oh, and of course, we're gonna need some labels to display the current vote count for each vote. So let's just do typography element. It's gonna be which one? decided just for now, let's just type to do. We're gonna implement it later, display the correct value. Okay, I think that's pretty much it for the layout. Later on below, we're also gonna add the notifications to display like a notification for a contract update. But for now, let's just leave it as it is. It's only imports the missing imports. So let's just go ahead and start it up to see what we have for now. So do npm start. It looks like we're missing some dependencies, so let's just install them. So let's emotion /react and emotion /styled. Okay, let's try again. Alright, it looks like it actually started up this time, so let's just go to localhost 3000, and yep, here we have the layout. Yeah, we don't have the counter implemented yet, so that's okay for now. Also the 2 buttons, so that's fine. Actually, let's just make this a bit smaller and the titles a bit bigger. So let's go back. Let's make this page 2. This as well. Okay. And yeah, let's make these ones actually H1. This one's gonna be iPhone. And this one's gonna be the yeah, that looks a bit better. Okay, so the next thing we're gonna do is load up the contract instance once the web page loads. So for that, I'm gonna go back to the code. And we're gonna define the use effect function. So this is basically just a piece of code that runs when the web page loads. First, we're gonna define the Senslate signer. So that's basically an interface to work with the Senslate wallet that we have installed in our Chrome browser. Let's just define a provider for it. Provider, okay. Get the signer itself. Signer, pass in the provider. And we're also going to define a reference to it. So signer reference is going to be ref Sensolid signer. That should be it. Okay, and now we're gonna fetch the actual deployed instance of the contract. So we're gonna just do a catch statement. So if it isn't found, it will just print an error. I just do something like that. Also need some way of storing the error, so just do like a React state error. Use state. Yeah. That. Set error here. Go. Right, and here let's actually fetch the instance itself. So we're gonna use the sCrypt service provider. So let's just do a script. Let's import it. All right. Contracted API and get latest instance. And in here, we're gonna pass in the actual class of the smart contract. So that's gonna be voting, of course, right? And the second parameter is gonna be just a JSON object with the transaction ID of the deployed contract and the index of the output that's contained within. Let's just go back to the browser. We already have the transaction ID here. I think that's it. Let's just copy it and paste it in here. And of course, we're also gonna store the instance in a React variable. So let's just do that, or let's just name it contract set contract, and not gonna use a string here, but the type's gonna be voting. Okay, and let's just set it in here. Set contract instance. Yeah, we also didn't set the sign. We're gonna do sign ref. The current is equal to sign. Oh, and of course, because this is an asynchronous function, we need to wait it. Yeah. Okay. Oh yeah, of course. This is gotta be async as well then. Oh, nope, apparently not. Yeah, let's just actually do it the old school way then. So we're gonna do this and then, and I get the instance, and we're gonna just set contract instance. I think that should work as well. Cool. Okay, so now we can move ahead and implement the onClick function that's gonna execute when we click on a thumbs up or a vote button. So what we're gonna do here is just define this click. Yeah, and we're gonna call the function, let's say, votes. Do the same on the second button. And now let's just define this function. Let's do it. It's gonna be synchronous function voting. It's gonna take in just an event. Here, let's just get our signer. So do signer reference dot current, and it's gonna be a sensitive signer. Okay. Yeah, okay, we're gonna need to cast it. So let's just this and do as set signer. Okay. Next thing is we gotta check if the contract is actually defined and also the signer, of course. Because if it's undefined, we can't really do anything, and function should just do nothing until they both got a value. Okay, so now we're gonna prompt the sCrypt wallet for an authentication. So let's just do this. Authenticated error. The function is gonna be request authentication. And if the user fails to authenticate, we're just gonna throw a simple error for now. Throw new error. Once authenticated, we can connect the Senselet wallet to our contract instance. So we're just gonna do connect with the sign. Oops. That's it. Okay, so now that we got the signer and the contract instance ready, the next thing to do is to iterate the smart contract and update value. So first, let's just create the next instance of the smart contract. So what we're gonna do is next instance and just do contract next. And now for this next instance, we gotta update the property values that we need to. And in this case, we gotta increment the counter for the candidate that we're voted for. So let's just get the candidate name. Candidate name. And we're gonna get it from the event target.name. And now let's just check which phone or candidate we actually voted for. So if it's an iPhone, and let's just this. Good. Okay, and inside of here, just gonna do contract candidates, and for the iPhone it's gonna be the first candidate, and yeah, just increment the counter. As for the second case, just do the same for the second candidate. Okay, now that we got the next instance ready. Oh, of course, I made a mistake. We actually need to update the properties of the next instance. Alright, so now we can actually call the deployed contracts public method on chain. We're gonna public method on chain. So we're gonna do contract.method dot, and the method is called vote. So we're just gonna call vote, and here we're gonna pass in the candidate's name. So it's gonna do byte string, just do candidate name true because it's UTF-8. Oh, I also noticed that we gotta capitalize this one, so yeah, I think that should be fine. Oh, we're gonna do the same one for Android. Yeah, this. I think that's good now. Yeah, the reason being because in deploy I actually capitalized it. So let's go back to the method call. And the second parameter is gonna be an object with the parameters for the method call. In this case, it's just gonna be the next instance. So this is the instance, and it's gonna be the next instance and the desired next iteration balance. So we could just write 1 here, or we can do contract balance. It's the same. The reason being because we deployed the contract with 1 Satoshi only. And because this is an asynchronous call, we can just do then inside we're gonna take results. We can just display it, and this result will contain the new transaction ID of the contract's instance. And also in case of an error, you can just simply set the error, and we will be able to display it later on. And maybe also log it to the console. Yeah, so I think that should be pretty much it as for the voting function. Oh yeah, it's called voting but vote. Yeah, and yeah, it should be fine. So let's just try it out. Let's try it out. So we still have the instance running in the background. Should auto update. Let's load the page. Also, oh, we get an error. Okay, yeah, so I think this is actually because of this. So yeah, because this fires many times, so we actually need to wait for it. So let's just define a separate function. Page contract example. Let's put this code in here. Or actually, never mind. Let's just fetch this within the vote function at the beginning, because this is an asynchronous function. You can just do wait. Like that. And set instance, set convert instance. Let's do that. I think this should be okay. So let's delete the old one. And maybe also this. Right. So let's try this out now. Okay. So now it loaded. So let's just make this a bit bigger. Okay, now let's try to vote. Okay, it looks like we forgot to either compile or load the artifact for our contract. So because we already compiled ours, we're just gonna load the artifact. So let's just do that. Let's go to index, and in here, we're just gonna import the artifact JSON file. So artifacts source artifacts, and should be voting.json. Oh, this, okay, and now just let's load it. Put artifact gonna import the class as well. That. And now upon opening the web application, the code is just gonna load the artifact, which is the compiled contract itself. Okay, so now let's try again. Let's just reload. Okay. Okay, so the wallet prompted us for our password. Right, and here's the request for the new transaction. That's gonna be the smart contract update. So let's just commit. Okay, and here we should have the transaction ID of the contract update. So let's just quickly check. Yeah, I think that should be it. Yeah, here we go. Okay, so now what's missing is to display the actual vote counter here and also display a notification once our vote has been received. Now, because we already have the latest contract instance locally, you can just go to the layout here where we have the to-do. You can just write contract. We're gonna put a question mark. It's gonna execute this code only if it already exists. We're gonna do candidates 0. That's the iPhone one, right? Votes received. The string. Let's just do the same one for the Android one. Here's gonna be index 1. Save. Let's check what we have now. Oh, okay. Oh, right. So when we voted, yeah, we got the instance before we actually did the update. So let's just actually move this into a separate function. Let's do async function fetch contract. I'm just gonna put this in here. Here, just gonna do fetch contract. Let's wait it. Then let's just do the same at the end. So we got the results of the contract call. Let's just do the same here. Actually, let's fetch it in both cases. And just for safe measure, we're gonna do the same in the useEffect function. So in this callback, I'm gonna fetch it as well, like that. So let's check the web page again. And all right, now we got the actual latest state of the contract. So that's great. Well, because our useEffect function keeps on repeating itself, we're just gonna do pass an empty array as the second parameter. So that should fix it. Oh yeah, it seems to have stopped now. Okay, good. Okay, so now instead of just simply printing the transaction ID into the console, we need some way of displaying it as a notification. So let's go back to the code, go down. Oh, let's just move this outside the header. So I accidentally put the table inside the header. Just move it out. Okay. Let's move down. Okay, now we're just gonna put in a snack bar element. We're gonna open it once an error exists. So this is gonna be the snack bar for in case an error occurs. We're gonna make it last for, say, 6 seconds. And in here, we're gonna put in an alert element. Alert severity. Oops. Error. And inside is gonna be the actual error message. Now let's do the same for success message. So, but we're gonna open it now. In case, yeah, we haven't stored the success data yet. So we gotta do that. We're gonna close it as well after 6 seconds. And inside it's gonna be an alert as well, but this time it's gonna be a success. And let's just leave this empty for now. Go up. Let's just define another React state variable. This time it's gonna be success. Set success. It's gonna be custom type success. Let's just define this type. So it's gonna be type success, and it's gonna contain the transaction ID, which is a string, and the candidate name, candidate, which is a string as well. Okay, and let's just initialize it with empty strings. So section ID, it's an empty string. Do this, and the candidate's gonna be an empty string as well. Okay, now let's move down and let's update this condition. So if candidate name isn't empty and the transaction E isn't empty, and inside here let's just put a string. Let's make it that the candidate got a vote. And because the data retrieved will be a byte string, we're gonna convert it back to a regular UTF-8 string. So I'm gonna use the function bytestring to, or never mind, let's just create a buffer from it. Buffer from this, and it's gonna be hex formatted. So we're gonna use hex parameter, and then we're gonna convert it to back to a string. And it's gonna be an UTF-8 string. Alright. Now that we can display notifications, we need a way of actually listening to calls to our smart contracts. So conveniently, the sCrypt service provider provides us with a subscription function for listening to these. So let's just go to the useEffect function and create a subscription. So we're gonna write sCrypt. It's already imported. We're gonna do contract API dot subscribe. The first parameter is gonna be the subscription options. So the first property of that will be the class of our smart contract. So we're just gonna pass in voting. And the second one is gonna be the contract ID, which we have to move into a global scope. So that's basically it. So the contract ID here and wait here, or actually here. And the second parameter of the subscribe function is gonna be the callback. So it's gonna take in an event. It's gonna be a type contract called event. We gotta also reference our smart contract class. So let's define the function's body. And in the body, we're just gonna do the success. So from the event, we can extract the transaction ID and also the candidate name. Candidate is gonna be the first argument of the method call, and yeah, just cast it to a byte string. Then we can also update the latest instance of the smart contract. So we're gonna do event next and first one. So this is just the next instance that the contract call will create. So the latest instance of the deployed smart contract. And let's also close this subscription once the app will be exited. So let's just do a cleanup function. And let's get a reference to this subscription. I'm gonna do subscription.unsubscribe. That's it. So now let's just try it out. Let's go back to the browser. Oh, let me just delete this header. It's in the way. Go back and let's vote for an iPhone. So again, just click commit. And yeah, we actually got a notification, so great. So if everything's fine, theoretically, if we open another client, so this could be any other computer around the world, doesn't matter, it will create a subscription to the same deployed instance. And if we update here, let's just update here. The other window should get a notification as well. And yep, it does actually work. Perfect. So I think this is a great point to finish the tutorial. So the full code of the whole project will be available on GitHub. The link will be in the description. So in case you have any feedback or any improvements to propose, just leave them in the comment section, or you can also go to the sCrypt Slack, where you can also find help as well. And I hope this was a nice presentation of how easy it is to quickly spin up a fully fledged application, a Web3 application using sCrypt on Bitcoin. And yeah, hopefully soon we'll have another video tutorial ready for you, so stay tuned, and until then, have fun.